Today we're going to take a look at law of sines. So, for example, if we have a triangle and we have 5, 3, and 6, and we need to solve it, we need to find these angles here. We don't have enough information. We can't use law of sines. So there's something called the law of cosines, and we're not going to derive it today. But you can derive it kind of like how we did the law of sines yesterday. There is a way to come up with this. So law of sines is a squared equals b squared plus c squared minus 2bc times the cosine of a. And now these letters you can switch around, but if this is little a, over here is capital big A, angle B. So if we had b squared, it would be a squared plus c squared minus 2ac times the cosine of capital B, angle B. And if this was c squared, it would be a squared plus b squared minus 2ab times the cosine of b, or c, excuse me. So again, we just need to make sure this c, if it's side c, it's angle c. Side b, it's angle b. So in order to use this, you could know 3 sides, all 3 sides, and 0 angles. Or the other option is you could know 2 sides and the angle included. And you'll see how this all works out in the examples. So let's see, if we scroll down to this first example, we are asked to solve it. So find all the sides and angles. So we have A, B, and C. So we have 120 degrees, little a is 9, little c is 5. So angle A is 120. We need to find angle B and angle C. Little a is 9, we don't know B, and C is 5. So we can't use law of sines, but we have 2 sides in the included angle. So let's say we want to find little b. So b squared equals a squared, the other sides, 9 squared plus 5 squared minus 2, and then those other sides again, times the cosine of 120. And let's see. So we have 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 120. So 151 is b squared. And then we go back, take the square root of that. So we have 12.3. So we know that this is 12.3, but we still have to find the angles. But now we can go back and use, we have an angle on the side opposite, so we can use law of cosines. Law of 120 over 12.3 equals, let's say we do the sine of A over 9. So 12.3 and 9, so 9 times the sine of 120. 12.3 times the sine of A, divide by 12.3. So 9 times the sine of 120 divided by 12.3, 0.633. And again, we're finding an angle. So we do the inverse. I'll just arrow up and grab that decimal. 39.3 degrees. Oh wait, sorry, I put that in the wrong spot. Okay, so A is 39.3. And then again, 180 in a triangle, so 180 minus 39.3 minus 120, and we have 20.7 degrees. Now this last example here, solve the triangle. A, B, C. A is 24, B is 40, C is 18. So again, can't use law of sines, we don't have an angle, but we have all three sides. And when you have all three sides, you want to start with largest angle. And the largest angle is opposite the largest side. So we're going to find B. So way at the end, we're going to have the cosine of B, which means on the other side, we have to have B squared. So 40 squared, and then it's the other sides, 18 squared plus 24 squared minus 2 times 18 times 24. So let's see, we got 40 squared, 1600, equals, now order of operations, we can't type this all in because this is multiplying here, so we have to break it apart. So 18 squared plus 24 squared, 900, minus, we can put that together because it's multiplying, 2 times 18 times 24, 864. And now we have to solve for the cosine of B. Again, this is multiplication, so we can't subtract those. It's kind of like saying we're solving 16 equals 9 minus 8x. We would never do 9 minus 8 is 1x. We have to isolate that x. So we're kind of isolating the cosine of B. So minus 900. So we have 700 equals negative 864 cosine of B. Divide by negative 864. So now we have 700 divided by negative 864. Let's see. Negative 0.810. And again, we have to do that inverse because we're finding our angle. So trig cosine. So 144.1 degrees. And then we could go and we could set up law of sines. So the sine of 144.1 over 40, the sine of A over 18. And then we practiced this yesterday and a little bit above, so I'll leave the rest for you to solve.